Well, we're back again, and as a reminder, down below the video are a bunch of links that have links to the indexes, and uh, I forgot what else is in there, but you can dig through those and see if there's anything fun there. Um, I haven't got anything done because I'm currently trying to move, and I have to be out of here in a week and a half, so I'm not getting anything done, and we'll see when that time expires. If I got out or not, and what's giving me my financial damages if I don't. So that's I guess that's all I have to say. So Terry, do you have anything you wanted to talk about?
Sure. Let's see. I'm going to share my screen here. I haven't had a whole lot of time, but why is this showing here? Okay. So I've now added this end cap over the quadrature encoder and bearing. And so go to this view. One of the things I was concerned about is, will water be able to get in here? So I made this little ridge on this piece, and then I created another part. And why is it not? Oh, that is going to be a second part, and I call it the TPU seal because it's going to be out of a TPU plastic 3D printed, which is a much more pliable plastic. And so it will act as a seal, and then I have this going on both sides of that seal to kind of crush it. And attach here. Then I've got a plane, and then I drop the rim down from this plane.
What's the more or less? What's the diameter, the outer diameter of your component there?
Oh, there it is. Um, that's saying 5 inches, but I don't think. Yeah, that is 5 inches. So the circle is 5 inches plus another ½ inch, because the diameter of the thrower, the two-sided blades, is 5 inches, or just under 5 inches.
The reason I ask is because I was going to rejigger my rear wheel odometry sensors, and I was looking at induction sensors measuring metal. But then I remembered you were working on an encoder here too, and
What size shaft do you have?
Well, I mean, I could just change it, but the design, but the shaft, I think at the moment is 5/8 inch.
Okay. I think if you change that, let me go to the encoder. Actually, I should have stayed there. Did I put it here? No, I didn't. Left side, quadrature encoder. Yeah, you should be able to then just change the diameter of the code wheel. Expand that to 5/8. I've got it at 1/2 inch because that's the size shaft I have. If you can slide that in, then you should be able to use this as is.
And TPU material, I'm not familiar with that. Is that something you 3D print or that's something
Yes,
you buy?
yes. The 3D filament is there's PLA, there's TEPG, no, PETG, there's ABS or PLA is, I don't know what it stands for, but that's kind of what the majority of people 3D print with.
Right.
It's
I've just never heard of TPU.
TPU is a much more flexible.
Mm.
Maybe you've seen these like squishy wheels for we use them in
That's
robot
okay. I'll look it
for
up.
taking them up, but it's a much more flexible material than the PLA, which is more of a hard, very rigid plastic.
Yeah. I'm more a PETG
Well,
user, but
I'm having a heck of a time getting my PETG, and it actually clogged one of my nozzles, so I had to wait to get 2 more nozzles, which just came today. So, but trying to get that dialed in because it uses a much different temperature profile than PLA, which I've been using so far. The TPG or the TPU, I was able to get to work just fine with the Cura slicer, but this PETG stuff, it just very stringy. It gets clogged around the nozzle.
yeah, it was a pain for me too to get it dialed in.
So I found a video that uses the Cura slicer and goes through each of the settings you need to have it work, at least on his 3D printer. It's not the same brand I've got, but at least it's the same slicer, so I at least know what I should be looking at to change.
Yeah, I don't think I'm not sure if I ever got PETG to work on a Bowden tube, but on my Prusa.
My Creator Pro does not have the Bowden tool. It has the direct drive extruder.
Yeah, that's what Prusa uses, and I was
Yeah.
able to ultimately get it to work.
And so let's see. The other thing, I've got it changed. I just haven't put it into this assembly where this will be a roller rather than just a static push bar, so that it'll be able to have a less friction when it's trying to push it out. I'm not sure whether I'm going to try working on getting the LED lights here, whether I'm going to try and get this side closed up, or whether I'm going to work on the exit chute for the snow. But those are kind of that, and then the having a place up here for all my electronics to go, and how I'm going to run wires and so forth. But that's kind of where I'm at. I've got plenty to do and not enough time to do it. So on to you, Al, I guess.
Yeah, and I was trying to see if my internet was working on my laptop. I think I'm still unable to share, so I'm just going to have to wave my hands and talk. If you go to Slack, you can see what I posted, and that's pretty much, I've got 3 or 4 things simultaneously in the mill. I got my cut metal back.
Do you want somebody to pull up the stuff on Slack to display it?
That'd be awesome if you wouldn't mind. Just start at the bottom. My green tinted pictures. I don't know why those dawn to dust lights, mercury vacuum tube or whatever they are, they give off a green tint.
Desktop 1. And I assume you can see that.
Yeah, just pull that one up. That's cool.
Let me get this stuff out of the way. Okay, so start with the first picture. Should we go back to your parts that you had? I don't know if that will put that in more context. I think if I can find those. Wow, wow, wow. Yeah, anyway, so somewhere you had there, maybe this one here. We'll start here.
There was an actual picture and then there was a CAD picture. That's the actual picture of the cut parts.
Yeah, I suppose I'd have to back up to find the CAD one. So anyway, this is you can explain what these parts are and how you did it or whatever.
Yeah, so using Fusion 360, I've tried Onshape and I've tried Fusion 360, but I was able to, for different reasons, Fusion 360 ended up working better for me to create DXF files for flat material to send to a guy who's he normally uses his plasma cutter to cut HVAC sheeting, but he's cutting this 1/4-inch stuff for me. And so those are the actual parts that went through the plasma cutter. And then,
So there's your CAD picture right there.
yeah. And so pay special note to that top right triangular shaped deal. That's going to have to be rejiggered. And I'll explain why. If you go down to the actual photo, where a couple days ago I was able to loose fit them.
Oh, you want
and
the
dealing with a plasma cutter on.
Do you want this picture or the ones
The
below?
green tinted picture. Yeah, the ones below.
Actually, I think if I click on files here, what's this do? There you go. Do you see that?
I can. So yeah, that one's fine. So those are the cut parts, painted black, re-drilled because the plasma cutter leaves a little slack, and at cutting that thick of material, it's not a CNC machine. So we had to re-drill the holes, and that was just a loose fit to see if the holes were basically in the same or the right spot. They are. The gas tank is sitting there unfastened, so I've got to work out how to fasten the gas tank down there. But so that's in progress. The reason I drew attention to that triangular shaped piece of metal is because that's where the linear actuator to control the transmission is going to go, and that in this photo would go in the lower left hand corner that's in the foreground. And I've got that on and sort of dry fitting it, and looks like that's going to have to be redesigned and raise my linear actuator up a bit. I'm still confident that it will work, but it's just iteration number 2 to get the sizing right. In addition to that, let's see, I've got the parts and my PCB board ready for the radio control, and so I've got to solder that. Yeah, that linear actuator would go in the background of that on the lower right corner. Although you can't see the part. And then I also figured out how in Fusion 360 to model tires. So I did that because, as I mentioned briefly, was going to figure out how to use the induction sensor. Previously, I'd used a magnetic rotational sensor, and although that worked, it feels a little fragile because it's sort of 3D printed and whatnot, and I thought it would be more industrial to use the induction sensor. And so I had a posting about looking at different options for how to make the plate, and that's why I was showing interest in, Terry, how you were doing your
Do you get enough
deal.
resolution with that induction?
I don't know is the answer to your question.
Okay.
I was going to send a couple of tests to the plasma guy to see just how many ticks, so to speak, I could get. And I think if he can cut that one on the right, that's the highest resolution that I think he could do, and that's 39
Okay.
slots. And so
Your
the circumference
your sensor may not be able to see those though with that narrow of a gap in there.
Yeah, that's what I didn't know, is just how much of a gap that induction sensor needs. That's why I was going to do some tests. So that's going on, working out the wheel odometry, working out the linear actuator connector, working out my radio control. All of that's up in the air at the moment. So as Terry said, lots to do. Not enough time to get it all done. But keep working on it little by little. That's what's going on in my world.
So again, you're showing your coupler has a 5/8 inch shaft diameter. I think you might want to go measure your axles. I think they're 3/4 inch axles on a lawn tractor.
Is it? Yeah, I'll take a caliper out there and
So before you start buying parts, you know, measure at least once to see what you actually need there.
Roger that. Will do.
This was the
And
sensor there.
Yeah, that's the induction sensor.
And another thing, just to keep track of here, you can buy NPN or PNP sensors, so they act differently depending on what you're doing. And also keep in mind, it says it runs on DC 6 to 36 volts, but make sure when you put some arbitrary voltage on, make sure your logic line coming out is either 0 to 5 or 0 to 3.3 or whatever, so you don't blow out anything. So
I want to release that magic smoke.
Yeah, check that out ahead of time and see what that is. And this also back to MPJA, they sell these also, and I don't know if they have. Let's see, what's this thing called? Detecting distance. Inductive proximity sensor. So let me try this. Let me go up here and say, give me a new browser window. Well, I shouldn't be poking around here like this. Let's see, and stuff's in my way again. Over here.
Have you checked your internet at your new place yet?
I looked at all the different companies, and it's just a mess. So I have no idea what I should get, or I still have to do that. I'm still thinking if I go back to DSL, which is just a phone line, that might be a way to do that. So here's the two that they have, and you can see they're cheaper than the ones you were buying. And this one says PNP, normally open output, and then the other one is oh, come on. So then the NPN one, this is the one you saw. I assume it's the one that you just had, you're showing. And see, this one's even cheaper, but if you catch them on sale, they get down to like 275 or something a piece. Says they only have 5 units in stock right now. So anyway, they have them also. And since I was talking about the motors before, let's go back and look at motors. Well, I'll have to do it this way. Here's that.
There
Here's
it
that.
looks- Okay.
And I see they're $12.95, not on sale. And then they'll put them on sale for like $10 or something, or maybe less than maybe $9.95 or something. So that's something you get there. They have these other things that various things. They've got one. It's like a Pitman motor with a gear reduction and long lead screw. That's got a plastic nut on it. And I bought one of those, and the plastic nut is too small. And I spent like a week trying to loosen that up. I put like a Ajax cleanser on it, and I tried running it back and forth. And I finally just gave up on it. I should check to see if the brass nut will fit on this thing. But anyway, that's just you can dig through the motors here, and they got various clever things here that may or may not be what you want.
Okay.
So
Yeah,
anyway,
I've not looked at that site much.
yeah. So anyway, that's what that stuff was. What was I doing here? Let's see. So I'm still sharing my screen. It's not going to show me. Yeah. Okay. So do we need to see anything else on Slack or anything else, or should I shut my screen sharing off?
I'm good.
I'm good.
Terry, how were you using a compression fitting for your opto encoder? I forgot.
Combination. Well, it was going to be a tight fit, but then I also do have 2 set screws. But it's set screws within the plastic, so I mean it's not.
Yeah, it's probably going to survive a long time.
Given that it doesn't have a lot of inertia or mass to it.
Yeah, there's
and
no contact.
There's
right?
no contact, so it should be sufficient.
Yeah, I would think so too. Mine, if I use these induction sensors, there wouldn't be contact either. But I was just curious.
So speaking of screws and plastic, are people familiar with these things?
Yes.
Because you can take those, and Heathkit would make all their stuff. They'd have the big injection molded cases, and then they say, here, take this bag of these things, and you put your soldering iron. I think that's what they're doing right here. They're using a soldering iron. You stick it in there, that heats it up, and you press it down into the plastic, and then it locks itself in there. So that's something, if you're doing 3D printing, you might want to keep that in mind, that these are available, and you can get them in various sizes and shapes. And
one of the other coaches who has 2 3D printers, he's got an actual, it almost looks like a drill press, but it's got a like a soldering iron that you put, it's got a magnetic clip for holding them, and then you just kind of press fit it down.
well, since they're brass, a magnet probably won't
Right.
attract them, but
it holds it nicely.
But the one that Heathkit told you is, if you, back in the days where you get a Radio Shack soldering iron, so just a cheap soldering iron, and the tip on that would fit in there and contact the whole thing. So that worked out well. It's just quick, and you just heat it up, you just shove it down and pull the soldering iron away. and you didn't need to do anything special. But so anyway, just keep this in mind that these kind of things are available, and maybe there's other things like that in the 3D printing world that you can do this kind of stuff. So I just thought I'd bring it up.
Thank you.
I'm good.
You done, Terry?
I'm done.